Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dopa Jr., a math instructor at the University of Liberia. And in my today's video, I will be looking at proof of properties or proof of rules of differentiation. And in the previous proof, we did the proof of the constant rule by means of the first principle of derivative. So in this proof, we want to look at the proof of the constant multiplier rule, or some may call it the scalar rule. So we want to prove why or how is it that the derivative of c times x, where c is a constant and x is a differentiable function. So how c times x is equal to a constant. So let's get started. Now, like we said, we're going to use the first principle of derivative. And if you check our previous video, we derived this first principle of derivative, or we derived this definition of derivative by means of the limiting process. So we now want to prove this. The derivative, this d divided by dx, or we call it d by dx, indicates that you are about to differentiate this function. So it means the derivative of this function is equal to just c. So what is the function in here? So the function in here is f of x. So this is f of x function, right? So this is now cx. Now, if this function is f of x, which is cx, we know that in here we have f of x. So we're going to replace f of x now with cx. The next thing we need to do is to find f of x plus h. So that is very simple. It's just the aspect of changing this x with x plus h. And on this side, you do the same thing. You write your c and you change this x to x plus h. So you are done. So now let's go back. Now we have f prime of x is equals to the limit. So wheresoever we see f of x plus h, we want to replace it with cx plus h. Minus, we replace this one with also cx, all divided by h, as h is approaching 0. So this is equal to the limit now of c times x is cx, and c times h is ch minus cx, all over h as h approaches 0. So what do you observe? This cx and this cx cancel. So we'll now be left with a limit of ch all over h as h approaches 0. Now what do you observe? H and h also go out. So f prime of x is just equal to the limit of c as h approaches 0. And we know that the limit of a constant is also equal to a constant. So thus, we say the derivative of a constant times a variable, which is now raised to the first power, is just equal to that constant. So the derivative of a constant times a variable that is raised to the first power is just equal to that constant. So for example, the derivative of 2x is just equals to 2. The derivative of 5x is equal to 5. The derivative of negative 10x is equal to negative 10. The derivative of the square root of 3x is just equals to, now 3x is not under the square root. The square root of 3, and then you have times x is just equals to the square root of 3, and so forth. So thanks for watching. In next video, we will solve more problems on how we can find the derivative using this formula, the derivative of, a scalar times a function. Thanks ever so much. See you next lecture.